Welcome back, everyone. Ready for another deep dive? Today, we're exploring the world of quantum technology through the lens of a true pioneer, Otto Hahn.
Ah, Otto Hahn, a name that echoes through scientific history. This Nobel Prize winner's work, especially his discovery of nuclear fission, well, let's just say it's a pretty big deal.
Yeah, that fission. And we've got a fantastic source for our deep dive today, an essay by Yargo Schneepat that really delves into Hahn's life, career, and lasting impact.
Schneepat's work is a treasure trove of insights into the scientific landscape of Hahn's time. And what's fascinating is how it connects to the quantum tech we're only just beginning to grasp today.
It's like a bridge between past and future, you know?
Yeah.
Now, Schneepat paints a vivid picture of Hahn's early life. He was born in Frankfurt at a time of incredible change and innovation. Think electricity, the telephone, groundbreaking inventions transforming the very fabric of society.
Absolutely. And Schneepat argues that this atmosphere of constant discovery really shaped Hahn's early interest in science. It was like a breeding ground for curiosity.
It's almost like he was destined to be a part of this scientific revolution. And speaking of revolutions, Schneepat highlights Hahn's early education, first chemistry, then a shift towards physics. Already, we see that interdisciplinary thinking that would become so crucial later on.
Right, that ability to bridge different fields. And here's a fun little tidbit from Schneepat. Hahn's doctoral work actually focused on bromine derivatives. Not exactly what you'd expect from a future nuclear pioneer.
It makes you wonder, doesn't it, about those unexpected twists and turns in a scientist's journey. But even in those early days, Schneepat points to the crucial role of mentors in shaping Hahn's path. People like Emil Fischer and Ernest Rutherford.
Ah, giants in the field. Schneepat emphasizes that these weren't just brilliant scientists. They taught Hahn how to think like a scientist, how to approach problems in a unique and creative way.
It's like learning from the masters, absorbing their wisdom and their methods. And soon, Hahn took a leap into a brand new field, as Schneepat details. He moved from pure chemistry towards radiochemistry.
Now, this was cutting-edge stuff at the time. Essentially, it was merging chemistry and physics to explore the mysteries of the atom, a field ripe for discovery.
And Hahn wasted no time diving in. Schneepat describes his meticulous work with radium and mesothorium, analyzing their properties in decay chains. Essentially, he was figuring out how these radioactive elements transformed over time.
And keep in mind, this was before we had the full picture of the atom. Hahn was piecing together an incredibly complex puzzle with, well, invisible pieces.
It's mind-boggling when you think about it. And it was during this period that Hahn began his long and fruitful collaboration with Lise Meitner, a brilliant physicist in her own right, as Schneepat emphasizes.
Absolutely. A partnership that yielded some incredible results. But Schneepat reminds us that this collaboration also faced challenges due to the political climate of the time.
It's a reminder that science doesn't exist in a vacuum, does it? There are always external forces at play. But even amidst those challenges, Hahn and Meitner made a remarkable discovery, a brand new element, protactinium.
Try saying that 3 times fast. But seriously, as Schneepat highlights, discovering a new element is a pretty big deal, and this was just a taste of what was to come.
Right, and we're about to enter the era of Hahn's most monumental discovery. Get ready, folks, because things are about to get nuclear.
All right, so as we move into the 1930s, the pace of discovery really picks up. Schneepat describes this period as a time of intense research into the atomic nucleus. Scientists were bombarding elements with these newly discovered neutrons, and honestly, nobody quite knew what to expect. It was a thrilling but also uncertain time for atomic research.
And that uncertainty led to a truly groundbreaking discovery. Schneepat really captures the drama of this moment. Hahn and his colleague Fritz Strassmann were working with uranium, and after bombarding it with neutrons, they found something totally unexpected.
Barium.
Barium. I mean, can you imagine? It completely upended their understanding of what was happening. Schneepat emphasizes that this was nothing short of revolutionary. It meant they had split the atom. It's such a pivotal moment in scientific history. But here's where the story gets even more fascinating. While Hahn and Strassmann conducted the experiments, it was Lise Meitner, working in exile, who provided the theoretical explanation for what they had observed.
Ah, yes. Lise Meitner, such a brilliant mind. Schneepat highlights how this discovery was a true testament to scientific collaboration. It reminds us that great breakthroughs often come from bringing together diverse perspectives and expertise.
And sometimes, those breakthroughs come with challenges. Schneppe points out that Meitner's crucial contribution was often overshadowed. Even though it was a collaborative effort, Hahn received the Nobel Prize while Meitner's role wasn't fully acknowledged.
It's a reminder that scientific progress isn't always a straightforward path. There are complex human stories intertwined with those moments of discovery. But let's get back to the science for a moment. We've got this earth-shattering discovery, the splitting of the atom, but how does this connect to quantum technology? It seems like a huge leap.
Well, it is and it isn't, right? It's a fascinating evolution that Schneppe traces throughout his essay. While Hahn wasn't directly involved in quantum physics, his work really laid the groundwork for a quantum revolution.
Exactly. Think of it like this. Hahn provided the raw materials, the fundamental knowledge about nuclear processes, and then future generations of physicists working in the realm of quantum mechanics could build upon that foundation.
So it's not about a direct line from fission to quantum computers, but rather about a deeper understanding of the atom that opened up a whole new world of possibilities. Schneppe gives us some great examples of this, like what about nuclear instrumentation, the tools and techniques used to study and manipulate atomic nuclei. These tools, refined over decades thanks to Hahn's work, are now essential for researchers working on things like, well, quantum computing.
It's amazing to think about, right? The ripple effects of discovery. And it doesn't stop there. Schneppe even touches on the potential of nuclear data storage, storing vast amounts of information within the nucleus of an atom.
That's mind-blowing. It sounds like science fiction, but it's all rooted in the foundational work of scientists like Otto Hahn. But Schneppe also doesn't shy away from the more complex aspects of Hahn's legacy, right? The ethical implications of splitting the atom.
Exactly. The discovery of nuclear fission was a double-edged sword. It held immense potential for both good and bad. Schneppe reminds us that the same breakthrough that led to nuclear energy also paved the way for nuclear weapons.
It's a sobering reminder that scientific advancements don't exist in a vacuum. They have real-world consequences. So how did Hahn grapple with this? How did he respond to the potential for both progress and destruction stemming from his own work?
Well, according to Schneppe, Hahn was profoundly troubled by the use of atomic bombs in Hiroshima and Nagasaki. It really shook him. He became a vocal advocate for peace, for the responsible and ethical use of science. He recognized the immense weight of what he had unleashed upon the world.
It's a crucial lesson for all of us, especially as we enter an era of rapid technological advancement. Schneppe emphasizes that Hahn's later years were marked by this deep sense of responsibility. He even played a pivotal role in establishing the Max Planck Society, an organization dedicated to promoting ethical and collaborative research.
He really dedicated himself to ensuring that science serves humanity, not the other way around. It's a powerful legacy. It reminds us to approach scientific progress with both excitement and caution, to always consider the potential impact, the ethical implications of our discoveries.
Schneppe's essay leaves us with a lot to think about. From the intricacies of nuclear fission to the vast potential of quantum technology, it's a fascinating journey. But it also forces us to grapple with the complex, ethical questions that arise from scientific breakthroughs.
You know, at the end of his essay, Schneppe leaves us with a really thought-provoking question. What if, and this is fascinating, what if Hahn hadn't gone into chemistry? What if his early passion had led him down a different path?
Like what's Schneppe getting at here?
Well, he uses the example of botany. Imagine Otto Hahn, the botanist. Schneppe's point is that scientific disciplines, even those that seem vastly different, are interconnected in ways we might not always realize.
So Schneppet's suggesting that even a small change, a different path early on, could have a ripple effect on the course of scientific discovery, like a butterfly effect, right? Hahn chooses botany, and maybe nuclear fission happens later, or maybe it doesn't happen at all. And who knows how that impacts the development of quantum technology.
Exactly. It's a reminder that the history of science, like all history, is full of these turning points, these moments where things could have gone in a completely different direction. And it makes you wonder about all the potential breakthroughs out there. Maybe they're hidden in fields we haven't even considered exploring. Or maybe they're waiting for someone with a unique perspective to come along and connect the dots in a way that nobody else has before.
It really underscores the importance of curiosity, of keeping an open mind, of exploring all avenues of scientific inquiry. Who knows where the next groundbreaking discovery will come from, or what seemingly unrelated fields it will connect. So much of science is about making connections.
Couldn't agree more. It's like what we've been talking about with Hahn. His work in radiochemistry wasn't directly related to quantum mechanics, but it provided the essential foundation, the building blocks for those later breakthroughs.
It's amazing to think about how his legacy extends far beyond that one monumental discovery. From nuclear energy to quantum computing, Hahn's work has really shaped the world we live in.
And Schneeppat reminds us that this journey of discovery doesn't end with Hahn. It continues today, and it will continue into the future. There are still so many mysteries to unravel, so many questions to answer.
And on that note, a huge thank you to Jurgo Schneeppat for this incredible deep dive into the life and work of Otto Hahn. We've included links to his essay and some other resources in the show notes for you to explore further.
Definitely check those out if you want to delve deeper into this fascinating story. It's a great read for anyone interested in the history of science, the impact of scientific discovery, and the enduring power of human ingenuity.
And until next time, keep exploring, keep questioning, keep diving deep.